Hello, my name is Jonathan Haynes from Tour de Force Consultants. It's a nice sunny day in the garden, and I thought it's a good opportunity to do what will be hopefully the first in a series of videos explaining how I deal with my clients on various different subjects, mainly in the medical sector, which is where I specialise. So to start off, I think we talk a little bit about one of the areas that I deal with, which is infection control for hospitals. And this is really the business of something that has been in the news a lot recently throughout Europe and indeed throughout the world, which is infections that a patient gets when they're going to the hospital. They don't take it with them, it's what they get as a result of being in the hospital. Things that have been in the news very recently have been, for example, MRSA, which is probably the most well-known superbug, as the media will put it. And these have been increasingly common, and of course these are also linked with problems to do with the use of antibiotics. The issues to hospitals around the world is that this is arguably the most expensive issue to do with patient care, and the average hospital of 800 to 1,000 beds will actually spend somewhere in excess of €1 million a year purely related to infections within the hospital the patients contract while they're there. The most expensive part of these is infections related to surgical sites. Patients have had operations where they then subsequently contract an infection in the hospital, and sometimes in the worst case, the patient dies as a result, but in the slightly lesser cases the patient will perhaps need to have the operation redone. So as I say, the cost to an average hospital will be certainly in excess of €1 million, and globally the infection, the HAI as it's called, the Healthcare Associated Infection Cost, has been variously calculated as certainly over $1 billion and possibly nearer to $1 trillion. It's quite an extraordinary cost. So it's in the hospital's interests to reduce this occurrence of HAIs, and it's quite interesting how different hospitals in different countries have done that. And what we're going to particularly talk about just for a few moments is an infection control and surveillance system. And this is a computer software system that has been developed to help the infection control team, which is often a very small team of doctors, mainly nurses, operating in the hospital, whose sole aim is to undertake surveillance of the patients that are coming and going, not just the ones that are having surgery, but all patients, to trace and to watch and to follow, and if they can, to preempt infections that might be brought in and infections that might be around the hospital that could cause HAIs and the incumbent costs to the hospital. So one of the difficulties with this particular product line is that different countries deal with this in different ways. In France, for example, the emphasis is very much on people power, so there's a hierarchy of nursing staff that have been put in place to deal with this issue. In other countries they have different methods. In the States, for example, they're quite technology literate, and their system is based very much on cost. So in the States they have embodied technology to deal with this issue, and that is rapidly increasing in popularity. The interesting thing about the particular software application that my client has is that it is specifically focused on this area, and it works by being the sole system, effectively it's the sole method whereby a small team operating in a hospital can survey the entire hospital or even group of hospitals, which is very unusual because usually hospitals, as most big organisations, they're vertical. So any systems they're working are in the surgery area or in the wards or in the outpatients, wherever. It's quite very rare indeed to find a system that goes across the hospital. So the beauty of this particular system is that it interfaces with the hospital's own patient administration system, so that's all patients, admissions, discharges, transfers. All that information that already exists in the hospital comes in to a central screen, a central dashboard, especially for the infection control team. 24 hours a day, real-time information. In addition to that, obviously, critically important is the lab information. So the tests that patients have had while they're there, all that information, the results of the tests, is in the lab system. And client needs that inside the system as well. So that information is interfaced with the software, so that all the lab results, positive, negative, whatever they are, all the organisms that have been found, those results also come into the dashboard. So we've got all the patient whereabouts and transfers of discharges coming in, and all the lab information coming in too. And that's the basis of the system. As I say, that spans the entire hospital organisation, however many buildings. The client's got one particular hospital with 65 buildings and one woman having to look after the whole thing, which is clearly totally impossible. So with this system, she can sit there with her screen and she can see what's going on. One of the prime benefits of it is, for example, one well-known one, as I said, is MRSA. This is very commonly known. Another one is Clostridium difficile, Klebsiella, Escherichia coli. And certain patients can be carriers of these organisms. So one of the possibly the most important elements of these systems is to identify who the carriers are. So with this system you can tag, for example, a carrier of MRSA. So that as soon as somebody comes into the hospital, for whatever reason, they could be coming in with diarrhea and vomiting or just general sickness. But if the infection control people can see immediately that they're in, so Mr. Jones has come into the hospital, he's flagged up on the system as being a carrier of MRSA. That means he's identified as having had this before. He's got a tag, he's come into the hospital, and the system will flag up that he's there and where he actually is, which means that patient, instead of waiting in a queue with a dozen other people, possibly infecting them, can be put directly into isolation. And that as a single element of the system is incredibly valuable. Because you can imagine waiting times in hospitals can be 3 or 4 hours very easily, which gives a lot of time for somebody to possibly pass an infection on to somebody else. In addition to that, the system allows all manner of comparisons and contrasting and contact tracing to see who's been next to who in the beds, and to also undergo root cause analysis. So there was an outbreak in a particular part of the hospital, an outbreak of, let's say, MRSA. You want to find out why that happened so that it doesn't happen again. And so you can find out, on the system you can see who caught it first. You can contact trace that to see who else caught it from that person and why. What wasn't done? Why wasn't that person identified? Why were they put next to beds where people then subsequently caught the condition, the organism? So that system itself works incredibly well within an organisation, and as I say, can reactively allow surveillance of what's going on with the patients and the organism, but it can also act proactively. For example, if somebody's coming in with diarrhea or vomiting, which may well be related to a superbug, then that person, just in case, as a precautionary measure, can then be put in isolation whilst tests are done to find out what they're carrying. So you can see just on the basis of those couple of examples, the system is very valuable. And in fact, the goal is to reduce the rate of healthcare infection, or reduce the percentage of it, which currently in Europe is running between 6 and 10%. In undeveloped countries it can be as high as 15 or 20%. So that's the goal, and the system works by allowing the team to be much more proactive, much more efficient, saves them about 40% of their time on reporting, and allows them to do education of my patients as well as the general surveillance and control of HAIs. And obviously, the closer they can get to saving the $500,000 or the $1 million that they're losing, it's easy to imagine how the system will pay for itself very quickly. And that's what the system does.